Close your eyes and imagine looking into a perfect mirror. You see yourself reflected back, every detail exactly the same but somehow reversed. Your right hand becomes your left. Your smile curves the opposite way. Everything is familiar, yet everything has changed. Now imagine that the entire universe has such a mirror. Not a mirror you can touch or see, but something far more mysterious. Something that exists in the very fabric of reality itself. This is the world of antimatter. A perfect reflection of everything you know. Every atom in your body has a twin somewhere in the cosmos. Every particle of matter that makes up your skin, your bones, your beating heart, has an opposite dancing in the vast darkness of space. These twins are made of antimatter. They carry the same weight, the same size, the same shape. But they hold an opposite charge, like the north and south poles of a magnet. Think of an electron spinning around the nucleus of an atom in your fingertip. Somewhere in the universe, there exists a positron. It looks exactly like your electron, but it carries a positive charge instead of a negative one. It is your electron's perfect opposite. Its antimatter twin. The protons in your atoms, carrying their positive charge, have twins called antiprotons. These antiprotons carry negative charges, like mirror images of themselves. They dance through space, waiting for a reunion that would be both beautiful and devastating. Scientists first discovered this mirror world in 1928. A brilliant physicist named Paul Dirac was working with equations, the mathematical poetry that describes our universe. His equations kept suggesting something impossible. They whispered of particles that shouldn't exist. Particles with opposite charges. Mirror particles. At first, Dirac thought his equations were wrong. How could there be opposites to everything? How could the universe hide such perfect twins? But mathematics, like the stars themselves, rarely lies. The equations kept singing the same song. There had to be antiparticles. There had to be a mirror world. Soon, other scientists began finding these mysterious twins. They built machines that could peer into the heart of atoms. They watched particles crash into each other at incredible speeds. And there, in the shower of energy and light that followed, they saw them. Antimatter particles, appearing like ghosts made real. You might wonder where all this antimatter hides. If every particle has a twin, shouldn't the universe be half matter and half antimatter? Shouldn't we see antimatter stars shining in the night sky? Antimatter planets spinning through space? Antimatter versions of ourselves walking through antimatter forests? But we don't. When you look up at the stars, you see a universe made almost entirely of matter. Your matter. The same kind of atoms that build your body. The antimatter twins seem to have vanished, leaving behind only whispers and traces. This is one of the great mysteries of our cosmos. Scientists call it the matter-antimatter asymmetry. Long ago, when the universe was young and hot, there should have been equal amounts of both. Perfect balance. Perfect symmetry. But somehow, matter won the cosmic lottery. Antimatter became the universe's greatest magic trick. Now you see it, now you don't. Yet antimatter didn't disappear completely. It still exists, scattered through space like rare diamonds. High-energy cosmic rays streaming from distant stars sometimes carry antimatter particles. They travel for millions of years through the cold darkness, these lonely twins searching for their other halves. Deep in space, there are places where matter and antimatter still dance together. Near the swirling edges of black holes, where gravity bends space itself, particles and antiparticles appear in pairs. They pop into existence from pure energy, live for the briefest moment, then usually disappear back into the void. Sometimes, though, one twin falls into the black hole while the other escapes. The surviving particle flies away into space, carrying with it the memory of its lost opposite. These cosmic orphans travel the galaxy, reminders of the mirror world that once was. Scientists have learned to create tiny amounts of antimatter in their laboratories. They use machines called particle accelerators, giant underground circles where particles race at nearly the speed of light. When these particles crash together with tremendous force, they sometimes birth antimatter twins from the pure energy of impact. Creating antimatter is like catching starlight in your hands. It requires enormous energy and incredible precision. The antimatter particles that scientists make live for only fractions of seconds before they find matter particles and annihilate in flashes of pure light. But in those brief moments, they offer glimpses into the mirror world. When matter meets antimatter, something extraordinary happens. They don't just collide like two stones hitting each other. They transform completely. Both particles vanish, converting their entire mass into energy. Pure, brilliant energy that shines brighter than the sun. This process is called annihilation, but it's not destruction in the way you might imagine. It's transformation. It's matter and antimatter remembering that they are really two sides of the same cosmic coin. When they touch, they become what they were always meant to be. Light. Pure light racing away at the speed of light itself. Einstein showed us that matter and energy are different forms of the same thing. His famous equation, E equals mc squared, tells us that even tiny amounts of matter contain enormous amounts of energy. But when matter and antimatter meet, this equation reveals its full power. 100% of their mass becomes energy. No other process in the universe is so perfectly efficient. Imagine holding a paperclip made of antimatter. If it touched a regular paperclip, both would vanish in a flash of energy bright enough to power a small city for days. This is why antimatter is so precious, so dangerous, and so full of possibilities. As you drift towards sleep tonight, picture this mirror world floating through the darkness around you. Antimatter particles streaming through space, carrying the memory of the universe's earliest moments. Each one a perfect twin, a cosmic reflection of the matter world you call home. And in that quiet space between waking and dreaming, you might wonder what incredible things could happen if we learn to harness this mirror world's power. Imagine a time before time. A moment before moments. When there was no earth spinning beneath your feet, no sun warming your face, no stars to guide you through the night. There was only darkness. Perfect, complete darkness. And in that darkness, something was about to wake up. This was the beginning. Not just the beginning of planets and stars, but the beginning of everything. The beginning of space itself. The beginning of time. Scientists call it the Big Bang, but it wasn't really an explosion. It was more like the universe's first breath. A gentle expansion of possibility into the void. In that first instant, the universe was smaller than the period at the end of this sentence. Smaller than an atom. Smaller than anything you could ever imagine. Yet somehow, it contained everything that would ever be. All the matter that would become galaxies and stars. All the energy that would light the cosmos. And yes, all the antimatter that would become the mirror world. The temperature was beyond imagination. Trillions of degrees. Hot enough to melt atoms before they could even form. Hot enough to turn energy into matter and matter back into energy, like a cosmic dance where partners kept changing form with every step. In this incredible heat, something magical was happening. Pure energy was giving birth to particles. Not just regular matter particles, but antimatter particles too. They appeared in perfect pairs, like cosmic twins being born from light itself. For every electron that flickered into existence, a positron appeared beside it. For every proton, an antiproton. The universe was creating both sides of the mirror at once. Picture it like raindrops forming in a cloud. But instead of water, these were drops of matter and antimatter condensing out of pure energy. They materialized in the swirling heat, perfect opposites dancing together in the newborn cosmos. For a brief, shining moment, the universe held perfect balance. Equal amounts of matter and antimatter filled space. If you could have watched from some impossible viewpoint, you would have seen particles and antiparticles swirling together like partners in an eternal waltz. Each matter particle had its antimatter twin. Each positive charge had its negative reflection. But this perfect symmetry couldn't last. Matter and antimatter are drawn to each other like lovers separated by time. When they touch, they transform into pure light. In those early moments, particles were constantly meeting their opposites and annihilating in brilliant flashes of energy. The universe became a cosmic fireworks show. Everywhere you looked, matter and antimatter were finding each other and becoming light. Flash after flash after flash. The cosmos blazed with the energy of a trillion suns, all from these tiny particles saying goodbye to each other in the most beautiful way possible. You might think this would continue forever. An endless cycle of creation and destruction. Energy becoming matter and antimatter, then matter and antimatter becoming energy again. A perfect, eternal dance. But the universe had other plans. As it expanded, it began to cool. Like breath on a cold morning, the cosmic heat started to fade. And as the temperature dropped, something mysterious happened. The perfect balance began to tip. For every billion antimatter particles, there were 1,000,000,001 matter particles. Just one extra matter particle for every billion pairs. It seems like such a tiny difference. Like having one extra grain of sand on an entire beach. But this tiny imbalance would change everything. As the universe continued to cool and expand, most of the matter and antimatter particles found each other and annihilated. Billions upon billions of perfect pairs transformed into light. The cosmos blazed with their final dance. But when the fireworks ended, when the last antimatter particle had found its matter twin, something remained. Those extra matter particles. One out of every billion. They had no antimatter partners to dance with. No opposites to transform with into light. They were left alone in the cooling universe, orphans of the cosmic lottery. These leftover matter particles became everything you know. Every atom in your body. Every grain of sand on every beach. Every star in every galaxy. All of it came from that tiny excess, that small victory of matter over antimatter in the universe's earliest moments. The antimatter didn't completely vanish. Some escaped into the depths of space, traveling for billions of years through the cosmic dark. Others hid in high-energy places where particle pairs still appear and disappear like quantum ghosts. But the great bulk of it transformed into the light that still fills the universe today. This light surrounds you even now. Scientists call it the cosmic microwave background. It's the afterglow of all those matter-antimatter annihilations from the universe's first moments. When you tune a radio between stations and hear that soft static, some of those whispers are echoes of the cosmic fireworks that chose our matter world over the antimatter mirror. The universe's choice seems almost random. Like flipping a coin that happened to land on matter instead of antimatter. But that single decision, made in a fraction of a second when the cosmos was younger than a heartbeat, determined that you would exist in a world of matter rather than antimatter. Scientists still wonder why this happened. Why did matter win? Was it truly random, like a cosmic coin toss? Or were there deeper forces at work, subtle differences between matter and antimatter that we're only beginning to understand? Some think there are slight differences in how matter and antimatter behave. Tiny asymmetries that gave matter a slight advantage in those crucial early moments. Others imagine that somewhere in the vast cosmos, there might be regions where antimatter won instead. Entire antimatter galaxies spinning in the darkness, filled with antimatter stars and antimatter planets. The mystery deepens when you realize how perfectly balanced everything had to be. If there had been too much extra matter, gravity would have collapsed the universe back in on itself before stars could form. If there had been too little, matter would have been too spread out to create galaxies and planets. The balance was just right. Just enough extra matter to build a universe, but not so much that it destroyed itself. As you settle into sleep tonight, you carry within your atoms the memory of that ancient moment when the universe chose its path. Every particle in your body is a survivor of the cosmic lottery that decided matter would triumph over antimatter. And yet, the mirror world still calls to us from across the darkness, holding secrets about what might have been, and what still might be possible. Look at your hand resting quietly in the soft light. See how peaceful it appears. How still and solid. But if you could peer deeper, past your skin, past your cells, into the very heart of the atoms that build you, you would discover something extraordinary. A dance so beautiful, so perfectly balanced, that it would take your breath away. Every atom in your body is like a tiny solar system. At the center sits the nucleus, dense and heavy, holding most of the atom's weight. Around it, electrons spin in their invisible orbits, moving so fast they blur into clouds of possibility. This is the world you know. The world of matter. But somewhere in the vast cosmos, there exists another hand. An antimatter hand, made of atoms that mirror yours perfectly. In those atoms, the dance is the same, yet completely reversed. The nucleus still sits at the center, but it's made of antiprotons instead of protons. Negative charges where yours are positive. And around this backward nucleus, positrons orbit instead of electrons. Positive charges where yours are negative. Imagine two dancers on a cosmic stage. One dressed in light, the other in shadow. They move with identical grace, identical timing, identical beauty. But where one steps forward, the other steps back. Where one reaches up, the other reaches down. Perfect opposites in perfect harmony. This is the relationship between particles and antiparticles. The electron in your fingertip has its twin, the positron, somewhere in space. They have the same mass, the same size, the same spinning motion. But the electron carries a negative charge, while the positron glows with positive energy. They are like two notes on a piano, perfectly matched in volume and tone, but tuned to opposite pitches. The proton in your atom's nucleus also has its dancing partner. The antiproton waits somewhere in the darkness, carrying the same weight but an opposite charge. Where your proton pulls electrons close with its positive attraction, the antiproton would push them away with its negative force. These cosmic dancers have been searching for each other since the universe began. When a particle finally meets its antiparticle twin, something magical happens. They recognize each other instantly, like lovers who have been apart for eons. They embrace. And in that embrace, they both disappear. But they don't simply vanish into nothingness. They transform into something even more beautiful. Pure energy. Light itself. The particle's entire mass becomes energy that races away at the speed of light, carrying with it the memory of their perfect dance. Scientists call this process annihilation, but the word doesn't capture its true nature. It's not destruction. It's the ultimate transformation. It's matter and antimatter remembering that they were never really separate. They were always two sides of the same cosmic coin, two faces of the same universal truth. When this dance of opposites takes place, it follows Einstein's most famous equation. Energy equals mass times the speed of light squared. Every tiny bit of mass becomes an enormous amount of energy. If just 1 gram of matter met 1 gram of antimatter, they would create enough energy to power a large city for an entire day. Picture a single ant, no bigger than your fingernail. If that ant were made of antimatter and touched a regular ant, their combined mass would explode with the force of a large bomb. This is why antimatter is both so precious and so dangerous. It holds more energy than anything else in the universe. The dance doesn't always end in transformation, though. Sometimes particles and antiparticles are born together but never meet. They spin away from each other into the cosmic dark, each carrying the memory of its opposite half. These lonely dancers travel through space for millions of years, hoping someday to find their perfect partner. In the depths of space, near black holes and neutron stars, this dance continues constantly. High-energy radiation creates particle pairs from pure energy. An electron and a positron appear together, spin briefly in each other's presence, then usually find each other again and transform back into light. It's like cosmic breathing. Energy becomes matter and antimatter, then matter and antimatter become energy again. Sometimes you can see hints of this dance in the northern lights that paint the sky in green and blue. When cosmic rays carrying antimatter particles hit Earth's atmosphere, they meet matter particles and annihilate in flashes of light. Those dancing colors above the Arctic are partly made from the final waltz of cosmic opposites. The dance of particles and antiparticles tells us something profound about the nature of reality. Everything in the universe seems to have its opposite. Light and darkness. Sound and silence. Matter and antimatter. These opposites don't fight against each other. They complete each other. They make the universe whole. Your body is made entirely of matter, but it exists in perfect balance with its antimatter reflection somewhere in the cosmos. Every electron spinning around every nucleus in every cell carries the potential for that ultimate dance. Every proton holds the memory of its antiproton twin. In some sense, you are always dancing with your antimatter self, even though you'll never meet. You exist because the dance between matter and antimatter in the early universe left just enough matter behind to build stars and planets anew. Your antimatter twin sacrificed itself in those cosmic fireworks so you could be here tonight, listening to this gentle story. The dance continues even now, all around you. In the air you breathe, cosmic rays create tiny amounts of antimatter that quickly find matter partners and become light. In laboratories around the world, scientists create antimatter particles that dance briefly before transforming into energy. The universe is always dancing, always transforming, always creating new forms of beauty from the meeting of opposites. As you drift toward sleep, imagine your atoms gently swaying to this cosmic rhythm. Each particle in your body holding the memory of its perfect opposite, its dancing partner in the mirror world. And perhaps, in your dreams, you might glimpse the incredible power that could be unleashed if we learn to harness this eternal dance. Deep beneath the earth, in rooms as quiet as ancient libraries, scientists work with something more precious than diamonds. More valuable than gold. More powerful than anything else in the known universe. They work with antimatter. And their greatest challenge is simply keeping it alive. Imagine trying to hold a soap bubble made of pure energy. One tiny touch, one moment of contact with anything at all, and it vanishes in a flash of light. This is what it's like to work with antimatter. Every antiparticle is like a delicate flower that wilts the instant it touches the regular matter world around it. The scientists who study antimatter are like gentle gardeners tending the most fragile plants imaginable. They work in sterile rooms, wearing special clothes, speaking in whispers. Not because antimatter can hear them, but because even the tiniest vibration, the smallest speck of dust, could destroy their precious cargo in an instant. Creating antimatter is like trying to catch lightning in your bare hands. Scientists use enormous machines called particle accelerators. These machines are tunnels buried deep underground, sometimes stretching for miles in perfect circles. Inside these tunnels, particles race at speed so close to light that time itself begins to slow down for them. When these speeding particles crash into targets, the collision releases tremendous energy. From this energy, like sparks flying from a cosmic forge, antimatter particles are born. But they appear for only the briefest moments. Fractions of seconds. Blinks of time so short that a heartbeat lasts forever by comparison. The first antimatter particles scientists ever created lived for less time than it takes light to cross a room. They flickered into existence and vanished before anyone could study them properly. It was like trying to understand a butterfly by watching it through a lightning flash. But scientists are patient people. They learn to work with these ghostly particles, even though each one lasted no longer than a whisper. They built detectors that could see antimatter's brief dance. They created chambers where the tiniest traces could be studied before they disappeared. The hardest part wasn't creating antimatter. It was keeping it safe. How do you store something that destroys itself the moment it touches anything? How do you build a container for particles that would annihilate with the container walls? The answer came from understanding that antimatter particles carry electric charges. Electrons are negative, so positrons are positive. This means they can be pushed and pulled by magnetic fields, like invisible hands reaching out to guide them. Scientists learn to build magnetic bottles. Not bottles made of glass or metal, but bottles made of pure magnetic force. These magnetic fields curve and swirl through empty space, creating invisible walls that antimatter particles cannot cross. The antiparticles float in perfect vacuum, suspended by magnetism, never touching anything solid. Picture a soap bubble floating in mid-air, but instead of air holding it up, invisible magnetic forces cradle it gently. The antiparticles spin and dance inside this magnetic embrace, safe from the matter world that would instantly destroy them. Creating these magnetic bottles requires incredible precision. The magnetic fields must be perfectly balanced, like a juggler keeping dozens of balls in the air at once. Too strong, and the fields would crush the delicate antiparticles. Too weak, and the antimatter would drift into the walls and vanish. The most advanced laboratories can now store antimatter for hours, sometimes even days. To scientists, this feels like forever. Each hour that antimatter survives in their magnetic bottles is a triumph of human ingenuity over the fundamental forces of the universe. But even with these miraculous magnetic containers, storing antimatter remains incredibly difficult. The tiniest vibration can disturb the fields. A power fluctuation can collapse the magnetic bottle. Even cosmic rays from distant stars can interfere with the delicate balance needed to keep antimatter alive. The amounts of antimatter that scientists can create and store are almost impossibly small. All the antimatter ever produced by humans, if gathered together, would weigh less than a grain of sand. Yet this tiny amount contains more energy than a large bomb. It's like holding the concentrated essence of a star in a space smaller than a dewdrop. Creating even these microscopic amounts requires enormous energy and resources. The particle accelerators that birth antimatter consume as much electricity as small cities. The magnetic storage systems need constant cooling to temperatures colder than deep space. The whole process is like using the entire ocean to fill a single cup. This is why antimatter remains one of the most expensive substances ever created. Each antiparticle costs billions of dollars to make and store. It would take millions of years of continuous production to create enough antimatter to power a car for a single day. Yet scientists continue their patient work, knowing that understanding antimatter might unlock secrets of the universe itself. In some laboratories, scientists have learned to create streams of antimatter particles. These streams are thinner than spider silk, made of antiprotons or positrons flowing in perfect lines through magnetic guides. The streams glow with their own inner light as stray particles occasionally meet electrons and transform into photons. Other researchers work with antimatter atoms. They've managed to combine antiprotons with positrons to create antihydrogen, the simplest antimatter atom possible. These antihydrogen atoms exist for only brief moments before they touch the walls of their container and disappear. But in those moments, scientists can study them, learning how antimatter behaves when it forms the building blocks of matter's mirror world. The tools scientists use to study antimatter are marvels of precision engineering. Detectors that can spot single particles. Computers that can track the paths of antiparticles as they spiral through magnetic fields. Sensors that can measure the exact moment when matter and antimatter meet and become light. Working with antimatter requires a special kind of patience. Scientists might spend months preparing an experiment that lasts only seconds. They might build equipment for years just to study a handful of antiparticles that exist for microseconds. It's like building a cathedral to hold a single candle flame. Yet in those brief moments when antimatter dances in their magnetic bottles, scientists glimpse something profound. They see the mirror world that existed at the universe's beginning. They touch the opposite of everything we know. They hold, for just an instant, the fuel that might someday power humanity's greatest dreams. As these dedicated researchers continue their gentle work, cradling impossibility in fields of pure magnetism, they edge closer to understanding how this cosmic mirror might one day be transformed from the universe's rarest treasure into something far more extraordinary. Perhaps, with enough patience and precision, they might even learn to build engines that burn brighter than the sun itself. Close your eyes and picture the most powerful engine you know. Maybe it's the roaring rocket that carries astronauts to space. Maybe it's the thundering jet that lifts airplanes above the clouds. These engines burn fuel and create tremendous force. But they waste most of their energy as heat and smoke and noise. Now imagine an engine so perfect that it wastes nothing. Every single atom of fuel becomes pure energy. Every particle transforms completely into light that races away at the ultimate speed. This is what an antimatter engine would be like. The most efficient engine that the laws of physics allow. When a rocket burns chemical fuel, only a tiny fraction becomes useful energy. Most of the fuel's potential stays locked inside, never released. It's like trying to light a room with a candle when you could use the sun. Chemical engines are wonderful for what they do, but they barely scratch the surface of what's possible. An antimatter engine would work on completely different principles. Instead of burning fuel in the way we understand burning, it would bring together the perfect opposites of the universe. Matter and antimatter. Positive and negative. Light and shadow. When these cosmic twins meet, they don't burn. They transform. Picture two dancers approaching each other on a stage made of starlight. One is dressed in robes of matter, the other in gowns of antimatter. As they draw close, they begin to glow. Their forms shimmer and blur. Then, in a flash of pure beauty, they become light itself. Not just any light, but the brightest, most energetic light possible. This is what happens when matter and antimatter touch. Einstein showed us that matter and energy are two forms of the same thing. But in most processes, only a small amount of matter becomes energy. Nuclear reactions, the most powerful processes we know, convert less than 1% of matter into energy. The rest remains locked in the leftover particles. Antimatter changes everything. When matter meets antimatter, 100% of both particles becomes energy. Nothing is left behind except pure light racing away at light speed. It's the universe's most perfect transformation. Complete and total and beautiful. The energy released from this cosmic dance is almost beyond imagination. If you could hold just 1 gram of antimatter in one hand and 1 gram of regular matter in the other, their meeting would create an explosion equal to 40,000 tons of dynamite. Yet the fuel would weigh no more than a paperclip. Scientists dream of building spaceships powered by antimatter engines. These incredible vessels would be lighter than feathers yet more powerful than any rocket ever conceived. They would accelerate smoothly and silently, pushed by streams of pure light flowing from their engines like invisible rivers of energy. An antimatter spacecraft wouldn't roar like chemical rockets. It wouldn't shake and thunder and belch smoke. Instead, it would glide through space as quietly as moonbeams, powered by the gentle meeting of cosmic opposites. The only sign of its tremendous power would be the brilliant stream of light flowing from its engine, beautiful as a comet's tail but brighter than lightning. These ships could travel at speeds that make our fastest rockets look like crawling insects. Where chemical rockets struggle to reach even a tiny fraction of light speed, antimatter engines could push spacecraft to significant portions of the cosmic speed limit. Journeys to nearby stars that would take thousands of years with chemical fuel could be completed in decades with antimatter power. The engine itself would be a marvel of engineering poetry. At its heart would be a reaction chamber where matter and antimatter meet in their cosmic dance. Magnetic fields would guide the particles together with perfect precision, like invisible conductors orchestrating a symphony of light. The chamber would need to be lined with materials that could survive the birth of pure energy. The walls would glow white-hot as photons of light bounced inside before streaming out through carefully designed nozzles. These nozzles would shape the light into a focus beam, directing the energy to push the spacecraft forward. Controlling such an engine would require incredible finesse. Too much antimatter, and the reaction would become too violent to control. Too little, and the engine wouldn't provide enough thrust. The fuel flow would need to be regulated with precision measured in individual particles. Each antiproton, each positron would need to be counted and guided to its meeting with matter. The fuel itself would be stored in those magnetic bottles we learned about, suspended in perfect vacuum by invisible fields. The spacecraft would carry tanks that hold no liquid, no solid, no gas. Instead, they would contain pure antimatter floating in emptiness, more precious than any treasure ever conceived. Starting such an engine would be like lighting a star. First, tiny amounts of matter and antimatter would meet in the reaction chamber. The resulting flash of light would heat the chamber walls until they glowed. Then, gradually, more fuel would be added. The light stream would grow stronger and brighter until it became a river of energy flowing from the ship. The thrust from this light stream would be gentle but relentless. Unlike chemical rockets that burn their fuel in violent bursts, an antimatter engine would provide steady, continuous acceleration. The spacecraft would gradually build speed, day after day, week after week, until it was racing through space faster than anything humanity has ever achieved. Passengers on such a ship would barely feel the acceleration. They would float in comfortable cabins while outside their windows the stars slowly shifted from points of light to streaks of brilliance. The universe would transform around them as they approached speeds that bend space and time itself. The dream of antimatter engines pushes at the boundaries of what's possible. The engineering challenges are immense. The energy requirements are staggering. Yet the potential rewards are beyond measure. These engines could open the entire galaxy to exploration. They could make the stars themselves our destination. As you rest tonight, imagine that gentle thrust of pure light carrying dreamers toward distant suns. Picture the quiet hum of an engine that transforms the very fabric of reality into motion. And wonder what it might feel like to harness such power that even time itself begins to bend around you. Time moves forward like a gentle stream, carrying you from one moment to the next. You wake up in the morning, live through the day, and fall asleep at night. Yesterday becomes memory. Tomorrow remains a mystery. Time seems as constant and unchanging as the stars themselves. But Einstein discovered something remarkable about time. It's not the steady, unchanging river we imagine. Time is more like flowing water that can speed up, slow down, even curve around obstacles. And the most powerful energies in the universe can bend this river in ways that seem impossible. Imagine standing beside a real river on a quiet evening. The water flows past you at a steady pace. But if you place a large rock in the stream, the water curves around it. If you narrow the riverbank, the water speeds up. If you widen it, the flow becomes slower and more peaceful. Time behaves in similar ways when it encounters massive objects or tremendous speeds. When you move very fast, time slows down for you. Not in a way you can feel, but in a way that can be measured. If you could travel at 90% of light speed for what feels like 1 year to you, people on Earth would age 7 years while you were gone. Time itself would be flowing at different rates for you and for them. This isn't science fiction. It's one of the universe's most beautiful and mysterious rules. Scientists have proven it with atomic clocks flown on fast airplanes. They've seen it in particles that race through laboratory equipment. Time truly does flow differently depending on how fast you're moving through space. Gravity also bends the river of time. Near massive objects like stars or black holes, time flows more slowly. If you could stand on the surface of a neutron star, where gravity is incredibly strong, time would crawl compared to Earth time. What feels like an hour to you would be many hours for people in weaker gravity. This is where antimatter enters the story of time. Remember how efficient antimatter engines can be. They can push spacecraft to speeds that are significant fractions of light speed. At such velocities, time dilation becomes dramatic. An antimatter-powered ship could journey to distant stars while its passengers experience much less time than people on Earth. Picture a spacecraft powered by the gentle thrust of matter and antimatter transformation. As it accelerates day after day, week after week, it gradually approaches speeds that make time itself behave strangely. The faster the ship goes, the more time slows down for everyone aboard. From the passenger's perspective, everything feels normal. Their clocks tick at regular intervals. Their hearts beat at steady rhythms. They age at the usual rate. But compared to Earth, their time is flowing like honey while Earth's time rushes past like a mountain stream. A journey to a star 20 light-years away might take the travelers only 10 years of their personal time if they can reach high enough speeds. But when they arrive and look back toward Earth, 40 years will have passed there. The trees they remember as saplings would be giants. The children they left behind would be adults with children of their own. This creates a kind of one-way time travel. The antimatter ship's passengers travel into Earth's future without experiencing all the years in between. They skip forward through time, carried by the incredible energies released when matter meets its perfect opposite. But antimatter might allow even stranger manipulations of time. Some scientists theorize that if you could create enough antimatter, concentrate enough energy in one place, you might be able to bend space-time so severely that the river of time forms loops and eddies. Einstein's equations suggest that under extreme conditions, the fabric of space and time could curve back on itself. Imagine the river of time flowing in a great circle, so that upstream and downstream eventually meet. A traveler following such a curved path through space-time might arrive at their destination before they departed. The energy required for such time manipulation would be enormous. You would need to concentrate the power of multiple stars into a small region of space. You would need to create gravity fields so intense they could trap light itself. This is far beyond anything humans can currently imagine building. Yet antimatter represents the most efficient way to generate such energies. The complete conversion of matter to energy that happens when particles meet their antiparticle twins releases more power per unit mass than any other known process. If you could gather enough antimatter, store it safely, and control its release, you might have the key to bending time itself. Some theoretical machines called closed time-like curves could allow travel into the past. These would require exotic materials and energies that may not exist in our universe. But if they could be built, antimatter would likely provide the power source. The engines of time machines would burn with the light of perfect transformation. Consider what this means. The antimatter floating in those magnetic bottles in today's laboratories might be the seeds of tomorrow's time machines. Each carefully controlled annihilation between matter and antimatter might be practiced for manipulating the very flow of causality. The passengers on such a time machine would experience something beyond current imagination. They would feel time flowing backward around them. They would watch effects preceding their causes. They would see light returning to the stars that emitted it. The fundamental order of cause and effect would reverse. But perhaps time travel into the past brings paradoxes too strange to resolve. What happens if you travel back and change something? What if the very act of time travel prevents itself from happening? These questions dance at the edge of logic and physics. Even if backward time travel proves impossible, antimatter-powered ships could still offer a form of time travel into the future. They could carry explorers forward through time at whatever rate they choose. Fast travel would mean rapid passage through Earth's years. Slow travel would let them savor each moment while the universe ages around them. The travelers would become masters of their own temporal destiny. They could choose to experience 1 year while Earth experiences 10, or 10 years while Earth experiences 1. Time would become as controllable as direction, as malleable as the stream of antimatter fuel flowing through their engines. As you settle into sleep tonight, time carries you gently forward at its usual pace. 1 second per second. One moment following another in perfect order. But somewhere in the future, antimatter engines might give humanity the power to navigate time like explorers charting unknown seas. And in that future, the very fabric of reality might prove to be far more flexible than we ever dared to dream. Imagine reality as a vast, invisible blanket stretched across the cosmos. This blanket is woven from space and time together, creating a single fabric that Einstein called space-time. You can't see this fabric, but you live within it. You move through it. Every step you take, every breath you draw, every heartbeat in your chest ripples through this cosmic tapestry. Most of the time, space-time feels perfectly flat and smooth. You walk across a room and space behaves exactly as you expect. Time flows forward at its steady pace. The fabric of reality seems as unchanging as solid ground beneath your feet. But the cosmic blanket isn't really flat. Massive objects create gentle dips and curves in space-time, like heavy stones placed on a stretched sheet. The sun creates a deep well in the fabric of reality. Earth rolls around the edge of this well, following the curved path that we call its orbit. When you drop a ball, it doesn't fall because some invisible force pulls it down. It falls because Earth's mass has curved space-time, and the ball is following the straightest possible path through this curved space. Gravity isn't a force at all. It's simply the shape of reality itself. This curved space-time is where antimatter's power becomes truly extraordinary. When matter and antimatter meet and transform into pure energy, they release more power per unit of mass than anything else in the universe. This tremendous energy can bend and warp the fabric of spacetime in ways that seem impossible. Picture dropping a bowling ball onto a trampoline. The heavy ball creates a deep depression in the stretchy surface. Now imagine dropping something much heavier. The depression becomes deeper, the curves more dramatic. With enough weight, the trampoline might stretch so much that it forms a funnel, bending back on itself. Antimatter annihilation can create similar effects in the fabric of reality. The concentrated energy from matter-antimatter reactions could theoretically warp spacetime so severely that it folds, twists, and curves in extraordinary ways. These distortions might create shortcuts through space and time themselves. Scientists call these shortcuts wormholes. Imagine the cosmic fabric folded like a piece of paper, with two distant points brought close together. A wormhole would be like poking a pencil through both layers, creating a tunnel that connects places that are normally separated by vast distances. Through such a tunnel, a spacecraft powered by antimatter might travel from one side of the galaxy to the other in minutes instead of millions of years. The ship wouldn't move faster than light. Instead, it would take a shortcut through folded spacetime, emerging at its destination almost instantly. But wormholes might offer even stranger possibilities. If the fabric of spacetime can be folded to bring distant places together, it might also be twisted to bring different times together. A wormhole could potentially connect not just different locations, but different moments in history. Picture the cosmic tapestry folded so that today touches yesterday. A traveler entering such a temporal wormhole could emerge in the past, walking through a doorway from now to then. The energy required to create such distortions would be enormous, but antimatter provides the most efficient way to generate such power. The mathematics of Einstein's theory suggest that these exotic space-time geometries might be possible. The equations don't forbid time travel. They simply require conditions so extreme that they challenge everything we know about energy and matter. Some scientists theorize about closed time-like curves, paths through space-time that loop back to their own starting point in time. Following such a path would be like walking in a circle through the fourth dimension, ending up when you started instead of where you started. These temporal loops would need to be powered by exotic matter with properties that ordinary matter doesn't possess. But antimatter, with its opposite charges and perfect energy conversion, might be exotic enough to warp spacetime into these impossible shapes. The energy requirements would be staggering. You would need to concentrate the power output of entire stars into small regions of space. You would need to create gravitational fields so intense they could trap light itself. The engineering challenges would make today's most ambitious projects seem like children's toys. Yet antimatter represents our best hope for achieving such impossible energies. Each gram of antimatter contains the same energy as a nuclear bomb, but concentrated in a space smaller than a marble. If scientists could learn to produce and control large quantities of antimatter, they might have the power to reshape reality itself. The spacecraft that could navigate these warped regions of spacetime would be marvels beyond current imagination. They would need to survive gravitational forces that could tear apart planets. Their hulls would need to withstand the stress of passing through spacetime distortions where the normal laws of physics break down. Inside these vessels, travelers would experience reality bending around them. They might see light from stars arriving before the stars emitted it. They might watch cause and effect reverse their normal order. The familiar flow of time could become as turbulent as rapids in a mountain stream. But perhaps the most beautiful aspect of these spacetime distortions would be their temporary nature. Unlike permanent scars on reality, the curves and folds created by antimatter energy would gradually smooth out as the energy dispersed. The cosmic fabric would heal itself, returning to its natural shape. The universe seems designed to protect its own consistency. Even if antimatter could provide the energy to bend spacetime into impossible configurations, reality itself might resist changes that would create paradoxes or contradictions. As you rest tonight, remember that you're floating on this invisible tapestry of space and time. Every moment, cosmic forces are gently shaping the reality around you. The fabric of existence stretches and flows in response to every star, every planet, every particle of matter and antimatter in the cosmos. And perhaps, in some distant future, travelers will learn to navigate this cosmic ocean by following currents that flow not just through space, but through time itself. The night sky stretches endlessly above you, filled with stars so distant that their light takes years, decades, even centuries to reach your eyes. The nearest star beyond our sun lies over 4 light-years away. At the speed of our fastest spacecraft, it would take tens of thousands of years to reach it. The galaxy seems impossibly vast, its spiral arms stretching across distances that dwarf human imagination. But what if the universe holds secret pathways between the stars? Hidden shortcuts that could turn a journey of millennia into a voyage of mere moments. What if the cosmic distances that separate us from other worlds are not as absolute as they appear? Einstein's theories whisper of such possibilities. They suggest that the fabric of space-time might fold and bend in ways that bring distant places surprisingly close together. These theoretical shortcuts are called wormholes, and they represent one of the most beautiful and mysterious concepts in physics. Picture a sheet of paper with 2 dots drawn far apart. In the flat world of the paper, an ant would need to crawl a long distance to travel from one dot to the other. But imagine folding the paper so the 2 dots touch. Suddenly, the ant could step directly from one location to the other, bypassing all the distance in between. Space itself might behave similarly. 2 regions separated by vast distances could potentially be connected through folds in space-time. A wormhole would be like a tunnel through these folds, creating a bridge between locations that are normally impossibly far apart. The entrance to such a tunnel might look like a sphere of twisted space, where starlight bends and curves in impossible directions. Approaching spacecraft would see the stars behind the wormhole distorted into strange patterns, as if viewed through a cosmic lens. The very geometry of space would be warped around the tunnel's mouth. But creating and maintaining a wormhole would require exotic conditions. The tunnel would naturally want to collapse, pinching shut like a deflating balloon. To keep it open, you would need matter with properties that ordinary matter doesn't possess. You would need negative energy, or matter that pushes space apart instead of pulling it together. This is where antimatter enters the story of cosmic highways. While antimatter doesn't have negative mass, it does carry opposite charges and might interact with spacetime in unique ways. The tremendous energies released when matter and antimatter annihilate could potentially be used to manipulate the fabric of reality itself. Some scientists theorize that carefully controlled antimatter reactions could generate the exotic conditions needed to stabilize a wormhole. The pure energy from matter-antimatter annihilation might provide the power to hold open these cosmic tunnels, creating permanent pathways between distant stars. Imagine a spacecraft approaching such a cosmic highway. The vessel would be powered by antimatter engines, its fuel tanks holding precious stores of antiparticles suspended in magnetic fields. As it nears the wormhole, the crew would see space itself behaving strangely around the tunnel entrance. Light from distant stars would curve and bend, creating rainbow arcs across the ship's viewports. The usual patterns of constellations would twist into unfamiliar shapes. Time itself might flow differently near the wormhole's mouth, creating regions where minutes stretch into hours or hours compress into seconds. Entering the wormhole would be like sailing into a river that flows through the heart of geometry itself. The spacecraft wouldn't travel through normal space, but through a shortcut that bypasses space entirely. Inside the tunnel, the usual rules of distance and direction might not apply. The walls of the wormhole might shimmer with exotic energies, patterns of light and darkness that exist nowhere else in the universe. Antimatter fuel would flow through the ship's engines, its annihilation providing the energy needed to navigate these impossible waters. Each particle of antimatter would transform into pure light, helping to maintain the delicate balance that keeps the tunnel stable. The journey through a wormhole might last only minutes, even though it connects regions separated by thousands of light-years. Passengers would experience the strange sensation of traveling vast distances without really moving at all. They would enter the tunnel near one star and emerge near another, having crossed the galaxy in less time than it takes to drink a cup of tea. But wormholes might offer even more extraordinary possibilities. If space-time can be folded to bring distant places together, it might also be twisted to connect different moments in time. A temporal wormhole could link the present to the past, or today to some distant future. Such time tunnels would require even more exotic conditions than spatial wormholes. The energies involved would need to warp space-time so severely that cause and effect themselves become tangled. The engineering challenges would make building a bridge between stars seem simple by comparison. Yet antimatter represents our best hope for achieving such impossible energies. The complete conversion of mass to energy that occurs during matter-antimatter annihilation releases more power per unit of fuel than any other known process. If any energy source could open doorways through time itself, it would be the perfect transformation of cosmic opposites. Scientists remain divided about whether wormholes could ever be created or stabilized. The mathematics of Einstein's theories allows them, but the physical requirements may be impossible to achieve. The exotic matter needed to hold them open might not exist in our universe. The energies required might be forever beyond our reach. But even if traversable wormholes prove impossible, the attempt to create them would advance our understanding of reality itself. Learning to manipulate antimatter on the scales needed for wormhole physics would require technologies that could revolutionize human civilization. The magnetic confinement systems needed to store vast quantities of antimatter would be marvels of precision engineering. The reaction chambers that control matter-antimatter annihilation would need to operate at temperatures and pressures that exist nowhere else except in the hearts of stars. Perhaps most importantly, learning to work with wormhole physics would teach us to see the universe in entirely new ways. We would discover that space and time are far more flexible than we ever imagined. We would learn that distance and duration are not absolute barriers, but challenges that the right technology might overcome. The cosmic highways that connect distant stars might remain forever beyond our reach. The secret pathways through space-time might exist only in the mathematical poetry of Einstein's equations. But the dream of such journeys pushes us to explore the deepest mysteries of reality. As antimatter research continues in laboratories around the world, each carefully controlled annihilation between matter and antimatter brings us closer to understanding the fundamental nature of energy and space-time. Each magnetic bottle that successfully contains antiparticles teaches us more about manipulating the forces that shape the universe. And in that growing understanding, we edge closer to answering one of the most profound questions imaginable: could the cosmic distances that separate us from other worlds prove to be nothing more than illusions, waiting for the right key to unlock passages through the very heart of existence itself? Perhaps the universe's greatest secrets lie not in learning to travel faster, but in discovering that the journeys we dream of are already much shorter than we ever dared to hope. Time moves forward like a gentle river, carrying causes downstream to become effects. You plant a seed today, and tomorrow a sprout emerges. You speak a word, and moments later someone hears it. The universe follows this simple rule: first comes the cause, then comes the effect. Always in that order. Always flowing in the same direction. But what if antimatter's incredible power could bend that river backward? What if the energy from matter-antimatter annihilation could curve space-time so dramatically that effects could travel upstream to meet their own causes? This is where time travel meets one of the strangest puzzles in all of physics. Imagine you could build a time machine powered by antimatter. The engine burns with perfect efficiency, transforming matter and antimatter into pure energy bright enough to warp space and time themselves. You climb aboard this miraculous vessel and journey backward through the years, arriving in the past when your grandfather was still a young man. In this earlier time, you have the power to change things. You could prevent your grandfather from meeting your grandmother. You could alter the course of events that led to your parents being born. But if your parents were never born, then you would never exist. And if you never existed, you couldn't have traveled back in time to make those changes in the first place. This is the grandfather paradox, one of the most famous puzzles in the philosophy of time travel. It's a loop of logic that seems to bite its own tail. The effect prevents its own cause, which means the effect couldn't have happened, which means the cause remains unchanged, which brings back the effect. Round and round the paradox spins, like a cosmic riddle without an answer. Scientists have spent decades thinking about this puzzle. Some believe the universe has built-in protections against such paradoxes. Perhaps time travel to the past is simply impossible, no matter how much energy you have. The laws of physics might contain hidden rules that prevent effects from preceding their causes. Others suggest that changing the past wouldn't alter your present but would create a new timeline branching away from the original. You could prevent your grandfather from meeting your grandmother, but this would create an alternate universe where you were never born. Your original timeline would remain unchanged, like a river that splits around an island. In this view, the universe is like a vast tree with countless branches. Each time someone travels to the past and changes something, a new branch grows. The time traveler comes from one branch but creates another, leaving both realities intact. The grandfather paradox dissolves because you're not really changing your own past, you're creating someone else's future. But perhaps the most beautiful solution to the paradox involves the universe itself acting like a gentle editor. Some scientists theorize that reality has a consistency protection principle. Events would conspire to prevent paradoxes from occurring. If you traveled back to harm your grandfather, something would always intervene to stop you. Maybe your antimatter-powered time machine would malfunction at the crucial moment. Maybe you would find yourself unable to approach your grandfather when it mattered. Maybe the very act of traveling backward through time would change you in ways that made altering the past impossible. The universe would protect its own logical consistency through what seems like cosmic coincidence. Another possibility is that time travel creates closed causal loops that were always part of history. Perhaps your journey to the past was always supposed to happen. Your presence in that earlier time might be what causes the very events that led to your existence. You don't change the past, you fulfill it. Imagine that your grandfather met your grandmother only because a mysterious stranger, who turns out to be you, introduced them at a crucial moment. Your time travel doesn't create a paradox, it completes a circle that was always meant to exist. The effect becomes its own cause, and the universe remains perfectly consistent. These temporal loops would be like rivers that flow in perfect circles, with no beginning and no end. The water that flows past any given point has always been flowing and will always continue to flow. There's no first cause because every point in the circle is both cause and effect. The energy requirements for such precise time travel would be staggering. You would need antimatter engines capable of generating gravitational fields comparable to those near black holes. You would need to control the annihilation of matter and antimatter with precision measured in individual particles. The slightest miscalculation could tear apart the fabric of spacetime itself. But perhaps the universe's resistance to paradoxes provides its own protection. Maybe time travel becomes easier when it preserves consistency and harder when it threatens paradoxes. The cosmic editor might guide antimatter-powered time machines along paths that maintain the logical structure of causality. In this gentle vision of time travel, your antimatter engines wouldn't fight against the universe's desire for consistency. Instead, they would work in harmony with the deeper patterns of cause and effect. The tremendous energies released by matter-antimatter annihilation would flow along channels already prepared by the universe's own logic. Time travelers would become partners with causality itself, their journeys carefully choreographed to preserve the beautiful dance between past and future. They wouldn't be rebels against the flow of time, but participants in a cosmic ballet where every step has always been part of the eternal choreography. The grandfather paradox might sleep peacefully in such a universe, never awakening because the conditions for its existence would never arise. Time travel would be possible, but only in ways that strengthen rather than threaten the logical foundations of reality. Perhaps the strangest aspect of these temporal mysteries is how they transform our understanding of free will and choice. If your time travel is guided by the universe's need for consistency, are you truly making free decisions? Or are you following a script written by the cosmos itself? Maybe freedom and determinism are like matter and antimatter, seeming opposites that are really two aspects of the same deeper truth. Your choices might be both perfectly free and perfectly predetermined, like a dancer who improvises within the structure of an eternal song. As you drift toward sleep tonight, time carries you forward at its usual gentle pace. One moment follows another in perfect order. Causes flow downstream to become effects. The river of causality runs clear and straight through the darkness. But somewhere in the quantum depths of possibility, antimatter engines might someday power vessels that navigate time itself with the same grace that ships cross calm seas. And in those future journeys through yesterday's tomorrows, perhaps travelers will discover that the universe's greatest magic lies not in breaking the rules of cause and effect, but in revealing how beautifully those rules were designed to accommodate the impossible. Pick up a small pebble and hold it in the palm of your hand. Feel its weight. Notice how ordinary it seems. Just a simple piece of rock, no different from millions of others scattered across beaches and hillsides around the world. But hidden within that innocent stone lies power beyond your wildest dreams. Every atom in that pebble contains tremendous energy locked away in its very structure. Einstein showed us this with his famous equation, energy equals mass times the speed of light squared. Even tiny amounts of matter contain enormous amounts of energy. But most of this energy remains forever trapped, invisible and unreachable. When you burn wood or gasoline, you're releasing only the tiniest fraction of the energy stored in matter. Chemical reactions rearrange atoms but leave the atoms themselves unchanged. It's like having a vast treasure chest and being able to spend only the coins scattered on top, while the real wealth remains locked inside. Nuclear reactions can reach deeper into matter's energy reserves. When uranium atoms split apart in nuclear reactors, they convert a small portion of their mass into energy. This process powers nuclear plants and lights entire cities. Yet even nuclear fission touches less than 1% of matter's total energy content. But when matter meets antimatter, something extraordinary happens. The cosmic twins recognize each other instantly and transform completely into pure energy. 100% of their mass becomes light racing away at the ultimate speed. Nothing remains except photons carrying the memory of what once was solid matter. This complete conversion is the most efficient process in the entire universe. No other reaction, no other transformation, can match the perfect energy release of matter-antimatter annihilation. It's like finally opening that treasure chest and discovering that every single coin turns into blazing sunlight. The numbers are almost impossible to grasp. If you could find the antimatter twin of that small pebble in your hand, their meeting would release energy equal to several nuclear bombs. A grain of sand meeting its antimatter reflection would power a large city for days. A single drop of water transformed with its antimatter twin could lift a mountain. Picture holding two marbles, one made of matter and one made of antimatter. Together they weigh less than a penny. But if they touched, they would explode with the force of the atomic bomb that ended World War II. That's the incredible energy density sleeping within the most basic building blocks of reality. This perfect efficiency makes antimatter the ultimate fuel for any journey, any dream, any impossible task that requires tremendous power. Where chemical rockets struggle to escape Earth's gravity, antimatter engines could accelerate spacecraft to significant fractions of light speed. Where nuclear reactors power cities, antimatter plants could power entire civilizations. But perhaps the most amazing possibility is using antimatter's energy to manipulate the very fabric of space and time. Einstein taught us that massive amounts of energy can curve space-time just as surely as massive objects do. The concentrated power from antimatter annihilation could theoretically warp reality itself. Imagine gathering enough antimatter to power a small star. The controlled annihilation of this cosmic fuel could generate gravitational fields so intense they bend light around them. Space would curve and twist in response to these artificial energy concentrations, creating regions where the normal rules of physics break down. In such warped regions, time might flow backward. Space might fold back on itself. The straight lines that light normally travels could curve into loops and spirals. The energy from antimatter could literally reshape the geometry of existence, opening doorways to places and times that seem impossibly distant. These energy concentrations would be like placing invisible weights on the fabric of reality. Just as a heavy ball creates curves in a stretched sheet, antimatter's energy would create curves in space-time. Spacecraft following these curves might find themselves traveling through shortcuts that bypass normal space entirely. The engineering challenges would be beyond anything humans have ever attempted. Storing vast quantities of antimatter would require magnetic bottles the size of cities, containing fields precise enough to hold individual particles suspended in perfect vacuum. The slightest malfunction could result in annihilation events that would dwarf volcanic eruptions. Controlling the release of such energies would demand technologies that don't yet exist. The reaction chambers would need to withstand temperatures hotter than stellar cores and pressures that could compress matter into exotic states. Every system would need backup systems, and those would need backups of their own. Yet the potential rewards justify any level of complexity. With enough antimatter fuel, humanity could reshape the solar system itself. We could move planets into more favorable orbits. We could kindle new suns to warm frozen worlds. We could even begin the process of stellar engineering, transforming ordinary stars into cosmic beacons that announce our presence to the galaxy. The energy from antimatter annihilation could power terraforming projects that turn barren worlds into gardens. Atmospheric processors could run for centuries on tiny amounts of antimatter fuel, slowly transforming alien skies into air that humans could breathe. Dead planets could be brought back to life with energy drawn from the perfect dance of cosmic opposites. Perhaps most remarkably, antimatter energy could power the preservation of civilization itself. As the universe expands and cools, as stars burn out and galaxies drift apart, antimatter could provide the energy needed to maintain islands of warmth and light in an increasingly cold cosmos. Future civilizations might harvest the quantum vacuum itself, extracting particle pairs and separating them into matter and antimatter reserves. They could build energy storage systems that last for geological ages, drawing power from the annihilation of carefully hoarded cosmic twins whenever their worlds needed warming or their spacecraft needed fuel. The technology to harness such vast energies remains far beyond our current capabilities. But every antiproton created in today's particle accelerators, every positron trapped in magnetic bottles, brings us one step closer to understanding how this ultimate power source might someday be controlled. In laboratories around the world, scientists work patiently with the smallest possible amounts of antimatter, learning the delicate art of creation, storage, and controlled annihilation. Each experiment teaches them more about manipulating the forces that could someday reshape reality itself. As you prepare for sleep tonight, that small stone rests quietly in your hand, its tremendous energy potential as invisible as the dreams that will soon carry you through the night. But perhaps someday, when humanity has learned to dance with matter's perfect opposite, even the gentlest dreams might be powered by the boundless energy that sleeps within every grain of sand, waiting for its mirror twin to wake it into blazing, transformative light. Mathematics is the universe's secret language. Hidden within numbers and equations lie the deepest truths about reality. When scientists dream of antimatter-powered time machines, they don't just imagine. They calculate. They write equations that describe the dance between energy and space-time, between possibility and limitation. These equations are like maps of the impossible. They show which dreams might someday become real and which must remain forever in the realm of fantasy. The mathematics doesn't care about human hopes or science fiction stories. It only cares about what the universe allows. Einstein's field equations are perhaps the most beautiful mathematical poems ever written. They describe how matter and energy curve the fabric of space-time. Every solution to these equations represents a possible shape that reality could take. Some solutions describe the familiar world around us. Others hint at exotic possibilities that stretch the imagination. Among these mathematical possibilities are closed time-like curves. These are paths through space-time that loop back to their own beginning, creating circles in time itself. The equations don't forbid such paths. They simply require conditions so extreme that they challenge everything we know about energy and matter. Creating a closed time-like curve would require exotic matter with properties that ordinary matter doesn't possess. You would need materials with negative energy density, substances that push space-time apart instead of pulling it together. The mathematics demands these impossible materials, but the universe might not provide them. This is where antimatter enters the elegant world of equations. While antimatter doesn't have negative mass, it does have opposite charges and might interact with spacetime in unique ways. The tremendous energies released during matter-antimatter annihilation could potentially create the exotic conditions that the mathematics requires. Scientists have calculated exactly how much energy would be needed to build a time machine. The numbers are staggering. You would need to concentrate the energy output of entire stars into regions smaller than atoms. You would need to maintain these conditions for extended periods while somehow preventing the concentrated energy from exploding outward at the speed of light. The Alcubierre drive represents another mathematical dream. This theoretical engine would warp spacetime around a spacecraft, contracting space in front of the ship and expanding space behind it. The vessel itself would never exceed light speed, but the warping of space could carry it faster than light relative to distant observers. The mathematics of the Alcubierre drive is elegant and precise. The equations show exactly how spacetime would need to be curved to achieve faster than light travel. But they also reveal the enormous energy requirements. You would need exotic matter with negative energy density, distributed in precise patterns around the spacecraft. Again, antimatter offers a potential path toward these impossible energies. While we can't create negative energy directly, the controlled annihilation of matter and antimatter might generate the exotic spacetime distortions that the equations require. The mathematics doesn't guarantee success, but it doesn't rule it out either. Wormholes present their own mathematical challenges. The equations show that these cosmic tunnels could theoretically connect distant regions of space-time. They could serve as shortcuts through the galaxy or even bridges between different moments in time. But the mathematics also reveals their fundamental instability. A wormhole would naturally pinch closed faster than light could travel through it. To keep the tunnel open, you would need to thread it with exotic matter that violates the normal energy conditions. The calculations show that this exotic matter would need to have negative energy density and very specific properties. Some scientists have explored whether quantum effects might provide the exotic matter that wormholes require. The vacuum of space is not truly empty but filled with virtual particles that pop into existence and quickly disappear. Under extreme conditions, these quantum fluctuations might be manipulated to create the negative energy densities that the mathematics demands. The Casimir effect demonstrates that negative energy densities can exist, at least on microscopic scales. When two metal plates are placed very close together in vacuum, the quantum fluctuations between them create a region of negative energy density. This effect has been measured in laboratories, proving that the universe does allow negative energy under special circumstances. But scaling these quantum effects up to the macroscopic level needed for time machines or wormholes remains an enormous challenge. The calculations suggest that the required negative energies would be incredibly difficult to create and even harder to control. The mathematics allows the possibility but sets the bar impossibly high. Energy conservation presents another mathematical constraint. The universe keeps careful track of energy, never creating it from nothing and never allowing it to disappear. Any time machine or faster-than-light drive must respect these conservation laws, and the equations show exactly what this means. Creating closed time-like curves would require borrowing enormous amounts of energy from the quantum vacuum, then somehow avoiding the need to pay it back. The mathematics suggests that this might be possible under very special circumstances, but the calculations are incredibly complex and the results remain uncertain. The uncertainty principle adds another layer of mathematical complexity. At the quantum level, energy and time cannot both be precisely determined. This fundamental limit might provide the loopholes that exotic space-time effects require, or it might set absolute limits on what can be achieved. Perhaps most importantly, the mathematics reveals the deep connections between seemingly different phenomena. The same equations that describe black holes also describe the theoretical engines of time machines. The mathematics that governs the expansion of the universe is closely related to the equations for faster-than-light travel. These connections suggest that antimatter-powered time travel, if it's possible at all, would require understanding the deepest principles of physics. You couldn't just build such a machine through engineering alone. You would need to master the mathematical poetry that describes the fundamental nature of reality itself. The equations are patient teachers. They don't reveal their secrets quickly or easily. Scientists spend years learning to read their elegant language, decades understanding their subtle implications. Each new solution opens new possibilities while closing others. As mathematical exploration continues, the boundaries between possible and impossible shift like morning mist. What seems forbidden by one set of equations might be allowed by another. What appears impossible under classical physics might become possible when quantum effects are included. The mathematics of maybe continues to evolve, guided by new discoveries and deeper understanding. Each equation is a question posed to the universe, and each solution is reality's carefully considered answer. And in that ongoing conversation between human curiosity and cosmic law, antimatter remains one of our most promising keys to unlocking the mathematical secrets that might someday transform dreams of time travel from elegant equations into extraordinary reality. Tonight, as you settle into the gentle embrace of sleep, antimatter particles are dancing through space around you. Cosmic rays carrying positrons and antiprotons stream silently through the darkness, having traveled for millions of years from distant stars. Some of these mirror particles pass harmlessly through your body, ghostly visitors from the universe's hidden half. In laboratories scattered across the world, dedicated scientists tend to their magnetic bottles with the care of gardeners nurturing the rarest flowers. Each captured antiproton represents years of work, billions of dollars of investment, and humanity's growing mastery over the fundamental forces of nature. These tiny prisoners of light may hold the keys to tomorrow's greatest adventures. The antimatter stored in today's laboratories weighs less than a whisper. All the antiparticles ever created by humans, if gathered together, would be lighter than a grain of pollen. Yet this microscopic amount contains enough energy to power a small city, enough concentrated potential to fuel dreams that span galaxies and centuries. Children born today might live to see the first antimatter engines ignite with the pure light of matter-antimatter annihilation. These future travelers might stand on the observation decks of spacecraft that accelerate smoothly and silently toward the stars, pushed by streams of photons flowing like rivers of captured starlight from their engines. The engineering challenges that seem impossible today will become the solved problems of tomorrow. Future scientists will learn to create antimatter as easily as we generate electricity. They will develop magnetic confinement systems that can hold vast quantities of antiparticles as safely as we store water in reservoirs. The dangerous and expensive will become routine and affordable through human ingenuity and patient persistence. Perhaps most remarkably, these future antimatter engines might allow humanity to explore not just distant places, but distant times. The tremendous energies released when matter meets its perfect opposite could provide the power needed to warp space-time itself, opening doorways through the fabric of reality. Imagine standing in a garden of possibilities, where every path represents a different future for humanity. One path leads to antimatter-powered starships that carry explorers to planets orbiting distant suns. Another winds toward time machines that allow travelers to witness the birth of stars or the formation of galaxies. A third stretches toward civilizations that harness the quantum vacuum itself, drawing unlimited energy from the dancing particles that fill supposedly empty space. The future might bring antimatter refineries that operate in the cold darkness between the stars, using stellar energy to create vast stores of cosmic fuel. Space-based factories could produce antiparticles by the kilogram, storing them in magnetic fields that stretch across the solar system like invisible highways of potential energy. These antimatter reserves could power the terraforming of entire worlds. Dead planets could be brought to life with carefully controlled annihilation reactions that warm frozen atmospheres and kindle protective magnetic fields. Barren moons could be transformed into gardens where future generations will walk beneath alien skies, breathing air created by the perfect dance of cosmic opposites. The descendants of today's children might travel through wormholes held open by streams of pure energy, journeying from one side of the galaxy to the other in the time it takes to dream a pleasant dream. They could explore the hearts of black holes, protected by exotic matter fields powered by antimatter engines. They might even venture beyond our galaxy, carrying samples of Earth's life to seed new worlds under foreign constellations. Time travel, if it proves possible at all, will likely require the ultimate energies that only antimatter can provide. Future time machines might be powered by the controlled annihilation of matter and antimatter on scales that dwarf today's most ambitious projects. These vessels could carry historians backward to witness the formation of the solar system, or forward to see the ultimate fate of the universe itself. But perhaps the most profound impact of antimatter mastery won't be technological but philosophical. Learning to harness the power of cosmic opposites might teach humanity about the deep symmetries that govern reality. We might discover that matter and antimatter are just one example of the universe's love affair with perfect balance and beautiful contradiction. The mirror world of antimatter reminds us that reality is far stranger and more wonderful than our everyday experiences suggest. Behind the familiar facade of solid matter lies a cosmos where particles can exist in multiple places simultaneously, where empty space seethes with virtual particles, and where the act of observation itself changes what is observed. Understanding antimatter has already revolutionized our view of the early universe. We now know that the cosmos began in perfect symmetry, with equal amounts of matter and antimatter. The slight imbalance that led to our matter-dominated universe is one of the great mysteries of modern physics, a cosmic coin toss that determined the nature of everything we see. Future discoveries in antimatter physics might reveal why this imbalance occurred. We might learn whether there are antimatter galaxies in distant regions of space, whether antimatter experiences gravity differently than matter, or whether the laws of physics themselves have a subtle preference for matter over antimatter. These fundamental questions connect to the deepest mysteries of existence. Why does the universe exist at all? Why do the laws of physics take the form they do? Why is there something rather than nothing? Antimatter research touches all these questions, probing the foundations of reality itself. The scientists working with antimatter today are like explorers mapping the shores of an unknown continent. Each experiment reveals new territories of possibility. Each antiparticle successfully stored and studied opens new questions about the nature of the universe. They work not just for practical applications but for the pure joy of understanding how reality works at its deepest levels. Their research proceeds with the patience of astronomers studying distant galaxies. Antimatter doesn't yield its secrets quickly or easily. Every advance requires years of careful work, precise instruments, and dedication to understanding rather than immediate application. But this slow, methodical approach builds knowledge that will endure for centuries. The children who will grow up to command antimatter starships are being born tonight. They will learn about matter and antimatter the way we learned about electricity and magnetism, as natural parts of a universe filled with useful and beautiful forces. What seems magical to us will be as familiar to them as sunlight. In their world, antimatter engines might power not just spacecraft but entire civilizations. Cities could run on the controlled annihilation of microscopic amounts of antimatter fuel. Weather control systems could use antimatter energy to guide storms and regulate climates. Even individual homes might have small antimatter power sources, no larger than today's batteries but capable of providing energy for years. The universe has been dreaming of these possibilities since the moment the first matter and antimatter particles appeared in the cosmic dawn. Every annihilation since then has been practice for the grand performances yet to come. Every laboratory experiment with antiparticles is a rehearsal for humanity's greatest adventures. As sleep carries you gently into tomorrow's dreams, remember that you live in the early chapters of humanity's antimatter story, when the first words are being written in a tale that might someday span not just the galaxy, but time itself.